Are you familiar with code smells? It's a kind of language for discussing suspect design and technical debt. And many development teams struggle with technical debt. So learning to recognise and name particular code smells could help you to discuss your suspect design and hopefully get it under control. So that's what this guided learning hour is all about. I want to give you and your development team an opportunity to talk about and learn to recognise some common code smells. Hi, I'm Emily Bache. I'm a software developer and creator of Salmon Coaching. This is a guided learning hour, and based on this video, you can lead this session on my behalf. I also provide some supporting materials. There are code samples and an activity board. You can get the code from my GitHub and a copy of the board via my Patreon. Do check that out. It could save you time if you don't need to create your own online whiteboard. Just use mine. Also, if you like this content, please subscribe to my channel and like this video. If you haven't seen one of these guided learning hours before, do take a look at my video, Guided Learning Hour How To, and also watch to the end of this one because the last part is a session briefing that explains more about how to run this session. I'm about to begin the part of the video that you can show your team, and it's marked with the chapter Gather Your Team, so you can start from there when you're ready. Hello everyone, I'm Emily Bache. Welcome to this guided learning hour. Today's session is about code smells, and we're using this shared whiteboard that everyone should have access to. What are characteristics of bad code? Have you ever met any bad code? How would you tell it was bad code? Each person write some notes about your experience of this. I'm guessing that you've got a frame covered in notes now, because I think most programmers have experienced bad code. Either code that someone else wrote that they just really don't understand, or code that you yourself wrote before you were as good at programming as you are now. There's lots of reasons for having bad code, and most people have met it in their careers. Kent Beck and Martin Fowler were no exception. They have also met bad code in their career. Perhaps the difference, though, is that they actually went as far as creating a language to talk about it and a language also of refactorings of what to do about it. So we've had previous learning hours talking about refactoring, but let's today focus on code smells. Now, a code smell, according to Martin Fowler, is a surface indication that usually corresponds to a deeper problem in the system. So it's something that's easy to spot that gives you a clue you need to do something. At the time, as the story goes, Kent Beck had a baby in the house, and he was then discussing with Martin Fowler about this phenomenon of, bad code, that you might need to do something. And what are we going to call that? And Kent Beck was thinking to his baby he had in his house, and he was like, smells. Because, if it smells, you probably need to change it. So that's where the term comes from. So what's important about code smells? They are quick to spot, easy to see. Even if you're not a very experienced programmer, you should be able to identify if there is a smell. But they don't always indicate a problem. There could be a good reason for the code being that way. You don't always have to take action. Once you've spotted a smell, you have to dig a little deeper and work out if there's something you actually need to do about it. And the important thing for today I want you to remember is that code smells have names, and this gives you a language for discussing problems in code that is still a little bit vague because, the thing with a smell is it might be a problem, but might not. So it gives you a less dramatic way to discuss it with your colleagues. In Martin Fowler's book, Refactoring, he lists 24 named code smells that he describes. And this is great, but I looked on his website and they are not listed on the website. All the refactorings are, but not the code smells. And I think this is an omission because, when I'm training people to talk about refactoring, I also want them to talk about code smells. And I needed a reference. So I took the liberty of creating such a reference on the salmoncoaching.org website. Here I've listed all of Martin Fowler's 24 smells and a couple more that I came up with just a short description of each one. So if you need to look up a code smell, you can check there. They're also listed on Wikipedia quite a lot of them, so I've also included links to Wikipedia on some of them. The code smell that I want to focus on today is long function, also known as long method. Whether it's a long method or function kind of just depends on which programming language you're using and whether there's a class involved. It's basically the same idea. If the function is too long, it will be difficult to read and understand. In a previous video on my YouTube channel, I showed sparrow decks, and this is a way to train your brain to recognize visual patterns. And we're going to use it now to train you to recognize the long method or long function code smell. In a moment, I'm going to show you loads of code samples. And each time that code appears, you need to decide whether the methods in it are too long or short enough. So you're going to say out loud either long or short. And a chorus of voices will join you as you speak, and the correct answer will appear on the screen. So this reinforces the learning. You see and hear and speak the correct answer. So do talk out loud. You have to make an effort to get the answer right too, because you want to practice making judgments and reinforce the correct ones. Over time, the slides appear for a shorter and shorter length of time, which is deliberate. Your visual processing is fast, and it gets faster as you learn. So get ready to say long or short.
Short.
Long. Long. Short. Long. Short. Long. Short. Short. Long. Short. Long. Short. Short. Long. 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 Short. Long. Long. Short. Long. Long. Short. 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 Long. Long. Short. Long. Short. Short. Long. 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 Short. Long. Long. Short. Long. Long. Short. 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 Long. Short. 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 Short.
long, short, long, long, short, 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 long, 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 long.
I hope that your brain is buzzing now with the long function and the long method code smell, and you'll be able to see it all over the place in a way that you never could before. I just wanted to mention there are quite a few different code smells that also have this property that they're very visual and that you could train your brain in this way to recognise them. So perhaps we'll have future learning hours on those ones. But for the moment, we're going to focus some more on long method. What we're going to do now is a kind of code reading test. And I'm going to show you first what to do on the tennis refactoring kata, and then you're going to do this exercise for yourselves. So I've got this code here in the tennis refactoring kata. And if I go to the C# version, there's a README file here with some code reading practice URLs. So the first thing I'm going to do is just open all of those in different tabs in my browser. So I've got 6 tabs open now, and I'm not looking at the code yet. I'm not quite ready to start. I've got a notepad prepared next to my screen where I can note down where I've detected the long method code smell in these code samples. The other thing I've prepared is a stopwatch on my phone so I can time how long it takes me to read this code. So I think I'm ready to start. I'll press start on the stopwatch and start reading the code. So this is tennis 1. Can I see a long method here? Yes, that looks like a long method. So I'm going to note that down on my piece of paper. Tennis game 1. Yep. What about 2? Yeah. So just by slowly scrolling through the code, I'm definitely spotting a long method there. So I'm going to write that down too. Tennis 2. Tennis 3. No, actually, that's it. No long method there. Tennis 4. So there's lots of methods here. I'm not spotting any really long ones though. Nope, not on that one. Tennis game 5. Yeah, now that's looking a bit long there. Yeah, I would count that as a long method. It's a bit strange looking. Okay, so I'll write down tennis game 5. Tennis game 6. Yeah, now that's definitely a long method. So write down 6 as well and stop the stopwatch. Yeah, so that was pretty much 1 minute to read those 6 files of code. And if I look now at my notepad, so this is what my notepad looks like now. I've written down those numbers and I'm going to also note down how long it took me, 1 minute 15. And then I can write that on a sticky note on the activity board. Here's the Miro board with my new note. And of course, in your case, there's more than one person in your team. You'll have more than one note. And then when you have all done this, you can have a little discussion. Was this useful? Did it help your code reading skills to do that sparrow deck? And what is the point of reading code quickly anyway? I mean, I think you can be a good programmer even if you read code slowly. But it could be interesting to discuss anyway. I don't want you to read tennis though. I want you to check for long methods in a different code base. It's called Office Robot Cleaner, and there are actually 12 versions of it. So plenty of spaces for you to have a look and see if you can spot a long function or a long method smell. Same exercise though, get a piece of paper, note down which ones have got the smell, note down how long it takes you, and then share your results and have a little discussion. So now you've had a quick look at this code, just long enough to spot code smells, I think it's probably a good idea if we spend some time addressing that code smell and doing some refactoring. I've picked out Office Cleaner 9 because it's got a very long method and lots of duplication that we can get stuck in and fix. So this is the Robots Cleaner class in the Office Cleaner version 9. And this is the code that you've just read, and hopefully most people have identified a long method in it. It's this one, clean floor. I'm just going to run the tests because we've actually got very good tests here and we want to make sure they're passing. And as we refactor, we'll continue to run them when we need to. So it's good to make sure they're green to start with. Okay, so what have we got here? Now I'm just going to fold up that switch statement. Now that shows me immediately that basically all the code in this method is in that switch statement. You can see there's like 100 lines of code there. So let's see what we can do about this. Now, we're switching on a direction, so the character, and it could be N. Now, I'm assuming that means north. So this whole case statement here appears to be moving the robot north. So I'm going to call that method move north that I'm just extracting. So this is the typical refactoring to do when you've got a long method, you extract method. And I'm just going to extract each piece of this switch statement to functions called move north, move south, move east, and of course, move west. I think this last bit must be. So now I've done that 100-line switch statement suddenly is much reduced and we can actually see all of the code on the screen at once. Great, so that leaves me to look more closely at these methods that we've broken out. Move west is still a bit of a long method, so I'm going to copy that and how does that actually compare with move east? So I've got move west in the clipboard, so if I select move east and then use my tools, it's got this facility compare with clipboard that I find very useful for detecting duplication. Yeah, we've got some duplication. Definitely. I mean, the comments are all the same to start with. And the structure with the for loop and the if statements, there's definitely lots of duplication here. Okay, so my goal now is basically to parameterize this so that I can use the same code for both move west and move east, just by passing different parameters. So let's have a look at that. Now, one of the things that's different is whether we're incrementing or decrementing x. So I think it would be useful to take this expression minus current x and expand that. So it will look more like something that we can parameterize. So I'm just going to take that expression and copy it, because if I do that afterwards here, so if I expand that to current x equals current x minus 1, and then change that expression there to just current x minus 1, I've introduced a small amount of duplication there, but I think it makes the code clearer and it makes it more susceptible to becoming a variable. There's another place where it does that actually just a bit lower down. So I'm going to replace that with the expansion as well. And now this expression, well, let's just run the tests. But now this expression current x minus 1 appears in 6 places actually. So if I extract that as a variable and call it next x, I think I'm well on my way to working out how to fix this duplication. And the tests are still passing. So I'm not going to actually do the rest of this refactoring here. I think you can work it out from here. Your goal is to address the long method, break it into pieces with extract method, and then fix the duplication by parameterizing. So it's your turn to work on Office Cleaner version 9. Address the long method code smell by using extract method, and then you can identify duplication in the extracted methods and use introduce parameter, ultimately, so that they can share more of the code. Just at the end of the session now, I'd like everyone to stop coding and write a note so that you can remember what you've learnt today about code smells. So please write on your note, if you had to explain the main idea of code smells to a colleague, what would you say? Put it in your own words. Great stuff. I hope you'll be watching out for those code smells today in your production code. And if you do find one, try and remember the official name for it so you can discuss it with a colleague if you need to. and hopefully sort it out. Happy coding! This is the session briefing, and it's intended for the developer or coach who's going to host the guided learning hour on my behalf. The idea is that you shouldn't need to be a full-time technical coach to be able to put together one of these sessions for your team. Any developer with a small amount of preparation time and some enthusiasm should be able to fix this.
In this learning hour, there are 4 places you need to pause the video and get people to do things. So the first is the connect, when everyone's going to write notes. The concept or concrete first exercise, where people are going to read some code and then you're going to facilitate a short discussion. We've got the concrete practice, where everyone's going to write some code, do some refactoring. And the conclusions, which is just a short session where everyone is going to write a note. So the first part that you need to facilitate is the connect. And this is where you're asking, how do you spot bad code? And at this point, everyone hopefully is writing notes because they've seen bad code before. And I'd be surprised, but sometimes it happens that people say, well, I've never seen bad code. It doesn't exist. It's just code that I didn't write. And, you know, it's fine. That is a valid viewpoint, that there isn't such a thing as bad code. But if you could just try to not get completely sidetracked and let that person take over, or maybe more than one, I don't know, and try and keep the focus on, yeah, but most people do experience bad code, and could you just kind of suspend your disbelief for the rest of the session? And we'll see if we can move on to the next part. The next time you pause the timer is when everyone is going to do an individual exercise to spot these code smells. And in the office cleaning refactoring kata, there aren't very many translations yet, but I suggest everyone just uses the C# version for reading. I mean, most people can read C#, even if it's not their main language. The other thing that you might need to facilitate here is, if you're working remotely, you could put each person in their own breakout room while they're doing this. And then when they've finished, they can come back to the main room and start the discussion. And close all the breakout rooms after a suitable time limit, like about 5 minutes. My experience, most people can read these 12 classes in something like 3 to 4 minutes. So if you set a hard deadline of 5 to bring everyone back, and then you're facilitating the discussion. The important part of this discussion really is that everyone has a chance to say, yeah, oh, this was fun. I found some long methods. What about you? And when you get into talking about whether this was useful and whether reading code like this is useful, I just want to make sure that you're there to make sure everyone feels safe. That you shouldn't feel like a failure if it took you a long time to read the code. I think you can still be a good programmer even if you're slow at reading code. But it might be an advantage to read it more quickly. For the refactoring exercise, there is a lot of duplication here. Hopefully, people will quite quickly be able to do the extract method for the first part, where you just need to make those 4 methods for moving the robot. The meat of the exercise is in the detecting the duplication and addressing it. So for this part, I think it's useful if people work in pairs so that they can talk about the problem and help one another. And you should also encourage them to use their refactoring tools and do this as safely as possible, and run the tests frequently. The conclusions just at the end of the session is a chance for everyone just to reflect on code smells as a concept and write down in their own words what they understand by that. And people remember better when they use their own words. So I think it is useful if people write a note, but in my experience, not everyone wants to. And I mean, that's fine. This is actually for them, not for you, but it does have the advantage if they do write a note that you get some feedback. Did they actually understand what a code smell is by the end of this session? So hopefully they all will.
I hope that you feel able to try out this session with your team now, because gaining more vocabulary for talking about technical debt should help your team to address these kinds of problems that you probably have in your production code. I hope you'll be able to try out this learning hour with your team, and if you do, leave me a comment about how it goes.